That means standard deviation is calculated from variance, where variance is calculated from mean of that. If I use this shortcut formula, you will get the result of the standard deviation. For the discrete series, standard deviation for discrete series, that is for individual series, n is equal to number of observations. Suppose if there are 10 observations, we will calculate the n. Hello and once again a warm welcome to one and all. It is Dr. Ravi Kumar YB, Department of Computer Science, Vidhyaashram, First Grade College, MYSURU, the Temple of Excellence. In today's class, you will be taught about the statistical methods. That includes the standard deviation. The standard deviation is the square root of the arithmetic mean of the squares of deviation of the items from the mean values. That means standard deviation is calculated from variance, where variance is calculated from mean of that. In statistical analysis, the standard deviation is considered to be a powerful tool to measure dispersion. The standard deviation is extensively used to measure standard deviation and is preferred over other measures of dispersion, like central tendencies, like mean, median, mode are also called as central tendencies. Over all those things, the standard deviation is preferred. It is the square root of the arithmetic mean of the squares of the deviations of observations from their mean value. It is generally denoted by this symbol sigma. That is, this standard deviation is indicated by this symbol. Calculation of standard deviation for individual series. For example, using direct method, this is the mean of that. Mean is equal to this, that is summation x high, where I is equal to 1 to n divided by n. This gives me the mean of that. Mean of that values. If that is the case, how can I calculate the variance? The variance is calculated by deviation. That is, deviation is calculated by x minus mean, where x is indicated by x1, x2, x3, x4, x5, so on like that. What is the value of x here? Maybe x1, x2, so on like the deviations. X are squared and their summation is divided by the number of observations. That means the number of observations which we have come across. The square root of the above calculations results in the deviation of the standard deviation. The formula is mentioned here, that is d square. That is the square root of this entire term. That means we have summation of square root of this term. That is summation of this x1 plus x2 plus x3 plus x4, x1 minus mean plus x2 minus mean. That is whole square of this. Please see to it here. That is d square. Plus so on up to xn minus mean whole square. That is the deviation from mean is identified by this individual observations. That is divided by, that must be divided by n to define it as the standard deviation. That is, the standard deviation is indicated by this symbol. So the shortcut method to identify that is this. The formula is this. That is, sigma is equal to square root of summation d square by n minus summation d by n whole square. Please observe that we have a square here for d and square here for the whole thing, that is d by n. If I use this shortcut formula, you will get the result of the standard deviation. That is, instead of doing this big thing calculations, that is this or this or this, we will have to incorporate the shortcut method. That is, the shortcut method is this, square root of summation d square by n minus summation d by n whole square. That is under the square root of that, which gives you the standard deviation using the shortcut method. Using the shortcut method. Step deviation method. This is also very, very important. The step deviation is indicated by this formula, that is square root of summation d dash square by n. The same thing, instead of d, I have a d dash here, that is indicated by the step deviation. Then see here, d dash, step deviation of the observations relative to the assumed mean. D dash square minus summation d dash by n whole square into c. What is the meaning of c here? That is, c is this. The common factor is generally referred to as c. So if that is the case, calculated as d dash is equal to x minus a by c. What is this x? X may be x1, x2, x3, so on up to xn. What is the meaning of a here? The term a indicates that is a mean of that. A is termed as mean. Then what is the meaning of c? Common factor which we have chosen there. So for the discrete series, standard deviation for discrete series, that is for individual series. Now we have the standard deviation for discrete series. The formula for this is similar to the mean, that is weighted average, which we find out. Similar to that, we have f is multiplied by there, that is the frequency of occurrence of this value, that is f into d square by n minus f into d divided by n whole square. The same thing, except the term f, we have everything. In the earlier case, we have the weights, that is frequency of values which is occurring, that is defined by this f, using this shortcut method. But actual mean method, we have this, that is square root of summation f into d square by n. This gives me the solution of the standard deviation. That is by using this direct method. This is by using the shortcut method. For which type of data? For discrete type of data item. Discrete type of data item. So for direct method, we have this formula, that is summation x square f into x square by n minus x whole square. This is whole square, where summation fx whole square is equal to sum of the squared observations multiplied by frequency step deviation method. The formula for this is already told you, that the step deviation method, using this, the same thing, except d, we have d dash here, where d dash is equal to, x minus a by c. The same thing is considered here for d dash. The d dash square by n minus summation f into d dash by n whole square into this term c. That is the common factor. So if that is the case, for continuous series, how can we find out the standard deviation for continuous series kind of data? Let me show you that. Sigma, that is standard deviation, is equal to summation of f into x square n. That means summation f into x square n. That is summation of this. Sigma is equal to this. F into x square is equal to sum total the square deviations multiplied by the frequency. That is f into x square. N is equal to number of observations. Suppose if there are 10 observations, we will calculate the n as the number of observations. In case of direct method, we have this frequency distributions. That is, one of them is continuous distribution. Other one is frequency distribution. And one more is continuous and frequency distribution is over. We have individual terms. Are considered here. Then we have the step deviation method as well. These step deviation methods are indicated by d dash, and the individual terms are represented by step deviation method is indicated by d dash, and the individual terms are represented by d, only d, that is d. Then frequency distribution, whether it is a frequency distribution or the normal thing, we are going to consider it as d. That is f into d square by n minus f into d by n whole square. That is the summation of this. That gives me the standard deviation method using the shortcut method. Similarly, if I introduce this summation f into d dash square by n minus summation f into d by n whole square with d dash, that gives me the shortcut method using the step deviation method. So similarly, we have summation f into m square is equal to sum of the squared midpoints multiplied by frequency. That is the step deviation by step deviation method. The formula is this: summation f into d dash square by n minus f into d dash by n whole square into c. The same thing which I have explained in the previous slides. D dash corresponds to the step deviation of the observations relative to the observed assumed calculated as value as d dash is equal to xi minus a by c. That is where xi indicates that, as I have already told you, that x1, x2, x3, where so on up to xn, where a is equal to mean of that. Then c is equal to, c is the value, that is a common factor value which is considered there, which is used to calculate the standard deviation. For this step deviation method, we are going to calculate the standard deviation. So where n represents the summation of the frequency, c represents the common factor chosen. In the shortcut method, this is the formula we are having, that is sigma, that is standard deviation is equal to square root of, under the square root of summation f into d square by n minus summation f into d by n whole square minus this. That gives me the value of this standard deviation. Please see to it here. Please see to it here. How to find a standard deviation? Let me give you the information of this in this session. The standard deviation is a quantification that measures the distribution, that is dispersion, of the data set relative to its mean. It is calculated as a square root of variance. Square root of variance. It is denoted by the Greek letter this sigma. If the deviation is greater than the dispersion, which will be greater, and if the deviation is lesser than the uniformity. Some of the definitions of the standard deviations are defined as: the standard deviation is the measure of the variations of all values from the mean. That is one of the definition. And the other definition is, standard definition is the square root of the sum of the squared deviations from the mean of that mean divided by the number of observations. That is the second definition. The third definition is, it is the square root of the variance. That is the third definition. So what is variance? A variance is indicated by sigma square, or sigma is equal to square root of, that is sigma square is equal to something. If I want to find out the standard deviation, then sigma is equal to, it becomes square root of something. That is the thing here we need to notice. That is sigma square is equal to something, that is summation I is equal to 1 to n x minus x bar, that is mean whole square by n minus 1. So if I bring this square under this, that becomes sigma square, that is sigma. Sigma is equal to the standard deviation. Then the sigma is equal to square root of variance. So variance, how can I define the variance? Variance is defined as sigma square is equal to summation I is equal to 1 to n minus 1 into xi minus mean whole square divided by n minus 1. This is called as the square. This is called as a variance. Square root of variance is, that is square root of this term, sigma square. This can also be represented as, that is sigma is equal to sigma square. The square root can be represented as 1 by 2. 2 gets cancelled. So obviously that leads to the standard deviation. That is how the mathematical calculation goes on. It is calculated at the square root of the variance by determining the variations between the data points relative to the mean. The higher the standard deviation, the higher the variance between each data set and the mean. The formula of standard deviation can be represented for this population standard deviation and the sample standard deviation. In case of population standard deviation, sigma is equal to, that is in case of this mean is represented by mu. that is xi minus mean whole square, that is the variance under the square root of variance. Or I can define it as the sigma is equal to 1 by n, summation I is equal to 1 to n xi minus mean, where xi indicates that both are same, and of course this is also same, this is also same, but the only thing is the convention I used here is by n. Instead of that, I have brought it to within the square root, that is 1 by n here. That's all. Where population standard deviation includes each element in the data, where I is equal to 1 to n, varies from 1 to n. The mean of all the elements of in the data sets, n is the number of elements, that is mean is equal to sum of all the elements divided by n, that gives me the mean of that. Sample standard deviations method, that is, yes, in case of this, the same thing, please observe this, notice xi, where xi is equal to x1, x2, x3, so on up to xn. For individual observations, x1 minus mean plus x2 minus mean plus x3 minus mean plus so on up to xn minus mean whole square. Please observe this, this has to be whole square. Everything must be brought under the root, square root of this, divided by how many terms are there? N terms are there. So if that is the case, n. Suppose if there are n minus 1 terms, let me bring it to n minus 1. That gives me the value of that. The same thing is represented here. Instead of n minus 1 written over here, I have brought it to this side. That is 1 by n minus 1 into that. Both are same. That is for sample standard deviation method. In this case, we first calculate the mean. All these are the textual information related to that. If that is the case, first calculate the mean, sum up all the values, divide by the number of elements. That is the mean, finding out the mean of that. Then calculate the deviation of the mean, that is individual terms, individual observations, where x1 minus mean plus x2 minus mean, that is whole square of that. That is whole square of that. That is done here in the step 2. In the step 3, square the deviations of that. That is this one. Square the deviations of that. This must be represented as d1, d2, so on up that. If that is the case, d1 square plus d2 square, so on up to is assigned to d. We will be getting d. So if that is the case, we have the third step. Square the deviations and add them together. The same thing which I have written over there. Divide the square deviation by the number of observations, that is n minus 1, divided by n minus 1. While using the population standard deviation, divide the sum by the squared deviation by n, that is the number of elements or observations, when you use the population standard deviation. When you use the sample standard deviation, that is in this case, you will divide it by n minus 1. In that case, you will divide it by n. In the sample standard deviation, you will divide it by n minus 1. Finally, in step 6, find the square root of the quotient that we get in the above step, that is in the 5th step, from the variance step. The values of the population and sample standard deviation depend on n. The larger the value of n, the greater the population and the sample standard deviation. Then, properties of the standard deviation includes, what is the property? The first one is, the value of the standard deviation is never negative, because it comes under the square root of that. If it is negative, negative into negative, that becomes a positive, so that leads to a positive value. It never becomes a negative. So the low deviation indicated that the data point tends to be very closer to the mean. Then the high deviation indicates that the data points is spread over a large range of values. If we add a constant to all the data sets, it does not affect the standard deviation. If we multiply a constant to all the data set, it affects the standard deviation. That the standard deviation can be 0 if and only if the observations have the same set of values. That is, it is a replica of the same thing. Then it is widely used in biological studies, statistics and all those things, and financial field. It is the fitting a normal curve, that is the frequency distribution curve, that is normal curve, or also called as a Gaussian curve. Then it is used in the measure of dispersion, that is mean, median and mode, for finding the central tendencies. It is also used in finance field to calculate the financial risk. All these are some of the properties of the standard deviation and its usage in various applications. With this, I am going to conclude this session. Thank you very much. Thank you one and all.